The
Yes.
the first Southeast Asian Games was held in 1961.
1961?
No, no. Sí.
Okay, let's see. We can see that this is an arithmetic progression. Do you remember arithmetic sequences?
Sí.
Okay, so the difference is 2. We can use the formula. We need 2n plus something. 2 is the difference, and it's the place that we are using. Okay. So if we use this, we need 2n plus something plus s, and we can get any element in the arithmetic progression. Okay. We know that if n is 28, we will get 2015. Okay, so we need to subtract. We need okay, minus 56. We will get 1959. Okay. So the formula for this progression, it's n equals 2n plus 1959. Okay. Si no hubiéramos tenido ningún salto, if the contest was held every 2 years, we can see that if n equals 1, we will get this. The first contestant will be 1961. But here it says it was not held in 1963. So we have to go 2 years backwards. Tenemos que irnos 2 años atrás, ¿no? Porque si no hubiera habido ningún salto y actualmente estuviéramos en el 28, sí habría sido en 1961. Pero como no se hizo en 1963, tenemos que irnos dos años atrás. ¿Sí? ¿Sí te queda clara esa, Sebastián? Do you agree? Hello, Sebastián?
No.
No? Okay, how do you solve it?
So if 2015 is the 28th, then 1999 is the 20th, 1979 is the 10th, 1969 is 10th, and 1967 is 5th.
Okay, a ver, let's see.
Yes.
Let's see with GeoGebra. Okay.
Okay.
Okay. The 28 contest was held in 1915. Okay.
Sí.
So 27 will be held in 12:13. Okay. And we can ask your Excel how to that he complete the table. Okay. Let's see. Nine, 8, 7, 6, 5, 4, 3, 2, 1. But here it says that it was held in 1961 and 1965, but not in 1963. Okay, so we need to make a skip here.
Sí.
This year does not count. So we will get 1959. Okay?
Okay.
Okay. Well, let's see. Suficiente enough.
12.
Okay, yes. Do you know how to get less common multiple?
Leave. Okay.
For example, okay, yes, the answer is 12. We can make 3 tables, 3, 6, 9, 12, 4, 8, 12, 16, 6, 12, and find what is the number that is repeated. Okay, but we can use some other techniques. For example, if we want to get the less common multiple, okay, 28 and for example, and 100. Less common multiple of 28 and 100. How can we get this?
Um, so they're both even. So would their least common multiple be 2?
2?
Okay.
No, that's the greatest common divisor or the greatest common factor. Yes. We need to get a name that it's multiple of 28 and 100. Necesitamos un número que sea múltiplo común de 28 y de 100. 2 is not a multiple of 28. 2, it's a divisor of 28. It's a factor. Okay. How do we get this? We're going to work with the less common multiple of two numbers. We need to factor the numbers. First, 7 times 2 squared and 5 times 2 squared. Okay? No, this is wrong. We need this. 5 squared times 2 squared. Okay? If we factor this number, those numbers, we will get this and this. Okay? If we want
No veo porque tengo vara.
¿No entiendes lo que estamos haciendo?
No veo the bottom part.
Of the screen?
Sí.
Okay, let me see. You can see this green line? No? You can see it.
I see it.
Okay,
Could you raise the lowest text?
okay. You need to... Debes minimizar tu pantalla y volverla a abrir. Un momento. En tu dispositivo minimiza la pantalla. You need to... Okay, no. Okay, let me see. Still don't see nothing? Okay. Okay, let's see. You can see this green line? ¿No?
Sí, pero no abajo.
Okay. ¿Esto todavía lo ves?
No.
No? Okay. You can see from here to... Okay. You can see only until here, right?
Sí.
Okay. Well, let's see. Okay. We are going to find the least common multiple of 28 and 100. You can see this?
Sí.
Okay. We need to factor those numbers. Least common multiple of 7 times 4 squared and 2 squared times 5 squared. Okay? ¿Sí? Si factorizamos los números, tendríamos 7 por 4 al cuadrado y 2 al cuadrado por 5 al cuadrado. Esto es 28, esto es 100, ¿sí?
Sí.
If we want a multiple, we need that the number include those numbers and those factors and those factors. Okay, this is wrong. This is 7 times 2 squared, okay? 7 times 4, it's 28. 4 times 25, it's 100. We want that, necesitamos un número que sea múltiplo de este y de este. Entonces, necesitamos y queremos que sea el menor. Lo mínimo que necesitamos es 2 a la 5. Yes? We're going to take this. No. We need 2 squared. That's the less that we need, okay? And we also need 5 squared because we need to get this number completely. Necesitamos construir este número completamente. Okay. And now we need a 7. So this number, it's multiple of 100. And this number, it's multiple of 28. Okay?
Okay.
So, for example, if we want the less common multiple of this, 2 squared times 3, 3 times 5 at 4, and 2 and 3 at 4 times 5 squared. Okay? If we want the less common multiple, we need that the number that we get contains completely to this number, contenga completamente este número y contenga completamente este número. So,
So, 2 squared
times
3 to the 4 times 5 to the 4.
Okay. So if we have 2 numbers, we need to get the greatest of the powers of every factor. Here we have 1 and 2, we will get 2. Here we have 3 and 4, we will take the greatest. It's 4. We have 2 and 4, we will take the 4. Okay? Yes, do you understand this idea?
Sí.
Okay. Well, let's see the next problem. This will be very easy for you.
Uh, 1 1 to 2.
Okay. We need to get, you can see the problem? You can see
Sí.
this? Okay. Dice, el diagrama muestra un triángulo sombreado dentro de un cuadriculado de 3×3. Encuentra la razón del área del triángulo sombreado al área del cuadriculado. Do you understand the problem?
Sí.
Okay.
Uh, 1, 2, 3.
1, 2, 3?
Sí.
No, because, okay. We need to find the radio of the shaded triangle, the area of of the grid. The grid it's 9. Okay,
So 4 to 9.
4 to 9. Okay, yes, it's, it's option B. Okay, okay. Let's see the next one.
Four.
Let me see, let me see. Why? I Can you explain your idea?
Yes.
Okay,
So it was that 6 and 8 are both factors of 24. So 1/6 is equal to 4/24,
okay,
and 3/8 is equal to 9 um 9/24.
okay, yes. Oh, yes, 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 yes. You are right. I was n is a fraction. I was using n uh over 24. It's a whole number. Okay, yes, you are right. 5 divided by 24, 6, 7, 8. Okay, you're right. Yes, yes. Okay, let's see the next one. This will be very easy.
12.
Okay. No, there are more. Okay. Here we have 1. In this floor, we have 4. In this floor, we have 6. And in the bottom, we have 9.
So 20.
Yes. The option D. 20. Okay. What is the largest number of parts that can be obtained from cutting a circle using 5 straight cuts? See. Okay, let's see. Okay, we need so many. Okay, 5 cuts. Okay.
See.
Uh, let's see. I'm going to do it this way. I have the circle. What is the largest number of parts that can be obtained from cutting a circle using 5 straight cuts? Okay. This will be the first one. Okay. If we have 1 cut, we will get 2 parts. This one and this one. Okay. Okay. Now we have 2 here. We have 2 more. Plus 2. Okay. Now in order to obtain the maximum of parts, we need that this line does not pass through this. We need that it makes something like this. Okay,
Sí.
I'm going to make this line. Okay. Here we have a little, very little part. We have 1, 2, and 3 new. Okay. Then here. Now I need to cut all the lines. I need to cut this one, this one. So now we get 1, 2, 3, and 4 new parts. Okay. Do you agree?
Sí.
And now I need to cut all the lines. So I will pass from here to here. And now we have 1, 2, 3, 4, 5 new parts. So we have 16.
Sí.
Okay. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay. That's correct. Okay. Yes. Do you agree?
Sí.
Okay. See, this one. Do you have ideas for solving this?
No.
Okay, let's see. We have months that have 28 days, 29, 30, and 31. Those are not common, but there are months that have 29 days, okay?
Sí.
So we are going to make okay, we have 4. Okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. If the month has 28 days, we will get for Mondays, for Tuesday, for Wednesday, etc. Okay. So if a particular month have 5 Fridays, Okay. But the month, if the month start here and it's a Friday, we can have 5 Fridays. Okay. Do you agree with that?
Sí.
Okay. But here it says that the first day it's not a Friday.
No,
So,
for the last day.
okay. The first and the last date of the month are not Fridays. Okay. Okay. If we have, so for example, if we have that this is a Friday, we will have here 1, 7, 8, 9, 10. No. 7, 14, 21, 28, 29, and 30. Okay. We can have that the first date is that the second day it's a Friday, the second of the month. We can have 5 Fridays, but we also need that the previous day it's a Friday. Okay. But if we have a 30 days month, we will have that the last day of the month will be also a Friday. Okay. So we need that the month has 31 days. The second day is a Friday, so we can have 5 Fridays. And uh, and the last day will be a Saturday. Do you understand the idea? Do you agree?
Sí.
Okay. So this kind of diagram, it's useful when we are working with days. Okay. Okay. Let's try this one.
Um,
Yes. Do you understand the problem number 9?
sí.
Okay.
Um, is it 27, which is none of the above?
Okay. No, you must see how many cubes are in the first floor.
Um, eight.
No,
Wait, but, uh,
we have
no.
3 times 2,
Ah,
6. In this floor, we have 6. Okay.
sí.
In this floor, we also have 6. And here we have 3. And if we rotate this one, we have those 3 that will fill these spaces, this part. So we only need to, okay, it's it's very ugly. My drawing is very ugly. We only need to add those numbers. And we have 18, okay? Do you agree? Do you understand this idea?
Sí.
Okay, let's try the problem number 10. A number gives a remainder of 2 when divided by 10. Another number gives a remainder of 3 when divided by 10. ¿Mm? No. La calle sí. La calle Matamoros. La ciudad de Matamoros, no. Do you understand the problem number 10?
Sí.
Okay.
Uh, wouldn't it give a remainder of 0?
Uh-huh. Yes, that's right. So, none of the above. Yes, the remainder will be 0. Okay. This number, we can write this number like 10n plus 2. The other number will have can be written like 10m plus 3. When we add those two, we will get 10n plus 10m plus 5. And if we multiply this by 4, we will get 40n plus 40m plus 20. And this is divisible by it. Can be divided by 10 with no remainder.
Sí.
Okay. Let's see the last. Just kind of contest, you only need the answer. So we can use some particular cases for solving. Do you have some idea for solving this?
No.
No? Okay. We are going to use a particular case. For example, we are going to use this. If the shaded area has an area of 3, 3, it's the radius of the shaded area to there. If this area was 3 centimeters, what will be this area?
It would be. Do you mean the unshaded area or the entire square?
Okay, the entire square.
It would be 10.
So the unshaded area will be 7. Okay. But we have here 2/5. A ratio of 2/5. So this is not the best. We can use it and we will find some decimal numbers. But if we use the minimum common multiple of 2 and 3, the last common multiple
Is
of the
6.
it's 6. If we use 6, this will be easier. If this is 6, this will be 14. Okay? Yes.
Sí.
And if we got this 6 and the ratio is 2/5, shaded over y, 6 over y will be 2/5 divided by 5. Okay?
Sí. It would be 6/15.
6/15. Okay. So y, it's 15. But we have already 6 square centimeters here. So we will have here 9. And finally, we will need the ratio of the shaded area, the total unshaded.
Which
Oh.
equals 6/48.
We need 3, no? 14, the unshaded area is 14 plus 9, 23. Okay,
Parecía 19 plus 9. Sí.
okay. Do you
Okay.
agree? ¿Sí? ¿Listo?
Sí.
Ok. Bueno, pues por hoy terminamos, Sebastián. Que tengas una bonita tarde. Nos vemos en la siguiente clase.
No.
Ok. Bye bye.